All right, so 10.3 is arithmetic sequences, and we already talked a little bit about this concept in 10.1. So in 10.1, we talked about this general form ELA for a term number. So your initial term plus one less times the number of differences, one less than your term number worth of differences. And we talked about how there seemed to be this pattern where the first and the last, and as you work your way inward, they all had the same value. And you can see that also in this example. Here there's a lot more terms than in my examples in 10.1, but you can see they're all 46. And so that lends us to a way of finding the sum, which we were talking about in 10.2 notes. The sum would be all of those terms. So from 1 to n, that's all of the terms to the nth term. You can only go to a certain number of terms. And so you have each term, and you keep changing from term 1 to term 2 to term 3 to term 4. All the way until term n, and so when you take the sum, the sigma, you get the sum. Now this can also be written because of this pattern, as I was mentioning, of having the same sum for the outer and then working your way to the inner terms. You can actually say, well, there's pairs of these, so it's the number of terms divided by 2, and then you add your first and your last together, because that's what you're doing for those sums. First and last, second from the first, second from the last, third from the first, third from the last, all the way in. So your first and last has the same value. So just that first plus the last times the number of pairs of them that you'd have. So for 10 terms, you'll have 1, 2, 3, 4, 5, half of them, because they're paired up. Pair meaning, so it's a 2. And so you can use this simpler version. This will be useful in some cases, but this in more cases. So you can see here for the first n terms, if we're doing the first 10 terms, the sum of the first 10 terms would be the sum of all of these. But it would be annoying to do if we had to go out to many more terms. It wasn't too bad to go to 10 terms, and we can verify that this works by writing it all out and adding them together. So generically, for the first 10 terms, you have your equation here. So for this specific one, the first 10 would be an n of 10. Your first term was 5. Your nth term, so in this case, your 10th one, 10 is your n consistently. For your 10th term, for your n of 10, you'd have 10, 10, and a sub 10, which a sub 10 is either found by having it given to you, or you might have to calculate it. So to find a sub 10, if you don't want to go out like this, you use the rule for the general term that we had before. So I plugged in my a sub 1 of 5. I plugged in my n of 10. Minus 1 is just minus 1. My difference being 4 between all of my terms. And so a sub 10 would be 41, which again I got when I just kept adding 4. So with an a sub n for 10, my a sub 10, because these have to match, a sub 10 is 41. Following order of operations, I end up with a sum of 230, which is the same thing I get if I actually add up all these together. I will have 5 of these 46s, which 5 of the 46s, so same answer. Here's another one. Find the sum of the first 8 terms. So in this case, your n is 8, so an 8 would go there and there. And to find your a sub 8, you need that in order to find your sum of the first 8, because you'll need your a sub 8 for this to work. And so then I plug in my n and my a sub 1 and my a sub n that I calculated over here. I get a sub 8. Simplify it, and I get 304 would be the sum. And the d being 10 was just me looking at the difference being 10. So this one's a little bit different. This one asks you to determine the number of terms. So this one we don't know the n. and we're given a sequence, and here we are given that the a sub n term would be 13, and the sequence has a sum of 48. So 48 is your S sub n, so you plug that in for your S sub n. You are looking for your n. Your a sub 1 is 3, and your a sub n is 13, and then you solve for your n. You can solve it this way, or at this point, if you want to get rid of the fraction, you can also do the LCD method. 2 times this, and then 2 times this term. Don't distribute it to these, because by doing it to this, you're actually doing it to that whole expression. And I believe that is it for 10.3. The main point of this being this sum formula, and you will often need to calculate your a sub n using the formula we had before, which is also right up here. Have a good night.